Welcome to your daily science news update. Okay, let's dive right into the latest breakthroughs.
First up, we've got 3 huge breakthroughs in health and medicine, and we're kicking things off with a really fascinating discovery that finally explains how exercise protects our brains as we get older.
So, you know how we've always been told that exercise is good for the brain? The how behind that has always been a bit of a black box. Well, guess what? It turns out the secret isn't in the brain at all. It's in the liver. Researchers at UCSF figured out that when you exercise, your liver pumps out this special enzyme. This enzyme then zips through your bloodstream, gets to your brain, and acts like this tiny molecular maintenance crew. It snips away a nasty protein that causes the brain's protective barrier to get leaky as we age. And by patching up that barrier, it cuts down on inflammation and, get this, it's even been shown to bring back memory function in older mice.
All right, next up, there's a groundbreaking trial for Parkinson's disease that is using a patient's own cells in a pretty mind-blowing way. Scientists are literally taking everyday skin or blood cells, and in the lab, they're turning back their biological clock. They reprogram them into what are called induced pluripotent stem cells. Think of these as master cells that can be guided to become almost anything, and in this case, they're coaxed into becoming brand new dopamine-producing neurons, which are the exact cells that Parkinson's destroys.
So what's the goal here? Well, in this pioneering Phase 1 trial at Keck Medicine, surgeons are implanting these freshly made cells right into the part of the brain that controls movement. The whole idea is to reboot the brain's natural ability to make dopamine. If it works, it could potentially slow the disease right down or even stop it and bring back motor function. I mean, we're talking about a huge step towards actually repairing the brain from the inside out.
Okay, our last story in the medical world is all about inflammation. You know, when you get a cut, that redness and swelling, that's acute inflammation, and it's a good thing. It's your body's healing crew rushing to the scene. The problem is when that process gets stuck in the on position. That's chronic inflammation, and it's incredibly destructive, driving everything from arthritis to heart disease. And for decades, the big question has been, how do you stop the bad inflammation without shutting down your entire immune system?
Well, it looks like scientists at University College London might have just found the answer. They've discovered the body's hidden off switch. It turns out there are these specific molecules derived from fat that act like a natural brake on the immune system. They work by targeting a very specific communication line, a signaling pathway that basically tells rogue immune cells to just keep on attacking. By finding a way to shut down just that one signal, we could create treatments that restore the body's balance, instead of just carpet bombing the entire immune system.
Hey, if you're finding this update useful, do us a favor and hit that like and subscribe button. It's the best way to stay in the loop on all the latest breakthroughs.
Okay, so we're going to shift gears a bit now. We're going from the microscopic world inside our bodies to the truly planetary scale, taking a look deep inside the Earth itself. So when you think of an earthquake, you probably picture the ground shaking, right? Something happening right up here in the crust we live on. But what if I told you earthquakes can happen much deeper, down in the hot, flowing mantle? Well, it's not a what if anymore. A team at Stanford has confirmed it's not only possible, but they've just created the very first global map of these deep mantle quakes. They've pinpointed and mapped 459 of these super rare events, some of them happening as far down as 50 miles below the crust. That is way deeper than we thought this kind of activity could happen.
So how did they do it? It was a really clever new technique. Imagine listening for 2 different sounds traveling through the Earth at the same time. One type of seismic wave, the SN wave, just cruises right along the upper mantle. The other type, the LG wave, vibrates really strongly, but only through the crust. So by comparing the volume, or the ratio, of these 2 different waves when they hit their sensors, they can tell with amazing accuracy whether a quake started way down in the mantle or up here in the crust.
All right, for our last section, we're heading out into the cosmos. We've got updates on a beast of a supermassive black hole and humanity's long-awaited return to the moon. Okay, remember M87 star? That's the famous supermassive black hole that gave us our first ever direct image a few years back. Well, now, using the powerful XRISM space telescope, astronomers are getting a completely new view of the chaos swirling around it. And this quote really nails it. It's like we've gone from looking at a still photo of a storm to actually being able to measure the wind speed inside the cyclone. And what they're measuring is just mind-boggling. This new data shows the storm of gas whipping around that black hole is more violent than 2 entire galaxy clusters smashing into each other. All that incredible energy heats up the gas so much that it can't cool down enough to form new stars. And that right there solves a huge cosmic mystery, why so many massive galaxies seem to just
Stop making stars.
And finally, let's bring it a little closer to home. Mark your calendars because NASA has officially targeted March 6, 2026 for the launch of Artemis II. This comes after a really successful wet dress rehearsal. So we're looking at 4 astronauts taking a historic trip around the moon. This is a huge deal. It'll be the first time humans have traveled beyond low Earth orbit since the very last Apollo mission, all the way back in 1972.
And that wraps up today's Science News Bulletin. We'll be back with another update for you in 24 hours.